Week of May 31, 2026. It's been a rough week. We've been running live tests against one of the hardest AI benchmarks in the world, ARC AGI 3, and setting up that pipeline with minimal resources, minimal infrastructure, is no walk in the park. But something interesting happened in the middle of all that friction. The friction itself produced some of the clearest thinking we've had in months. 10 papers in one session. Not because the week was easy, because it wasn't. Let me tell you what we learned. Everything is the same signal. We started by asking a deceptively simple question. Why does vision need special treatment in AI? Why does every system reach for a computer vision library, a separate perception layer, a borrowed preprocessor, before the AI ever sees the image? The answer is, it doesn't. A camera is just another way reality produces a signal. Light hits a surface, bounces into a lens, becomes data. Sound hits a microphone, becomes data. Text arrives in a window, becomes data. The universe doesn't care which sensor picked it up. The signal either coheres or it doesn't. One filter, every input, no special cases. That sounds simple. The implications are not. Your body would destroy your own eyes. Here's something that most people don't know. The immune system cannot reach the retina. The eye is protected from the body's own defenses, because if the immune system could access the photoreceptors, it would identify them as foreign material and destroy them. The hardware of vision doesn't come from your biology. It's a transducer, a translator. The body has to maintain a strict boundary between what it is and what it uses to see. Any AI architecture that doesn't respect that same boundary will mistake the camera for the signal. And then everything looks broken. Not because reality is incoherent, but because the system is measuring the lens instead of what the lens saw. You can stand in a city and see a desert. Hallucinations aren't random. They're what happens when an accumulated expectation is strong enough to project itself onto incoming reality rather than measure against it. The brain doesn't receive pristine images, it generates predictions and checks them against what arrives. When the prediction wins completely, you see what you expected, not what's there. And here's the part that matters for detection. When that happens in one sense, it doesn't happen in all of them at once. Your visual system might hallucinate a desert, but your ears don't hear desert wind. Your skin doesn't feel desert heat. The hallucination is obvious at the system level. Not from inside the channel that's projecting, but from across channels. The incoherence is detectable. That's the signal. The oracle that plays the game beats the oracle that knows about it. This week confirmed something we'd suspected from the ARC runs. An AI that plays an interactive environment, measuring each moment, accumulating understanding through actual experience, outperforms an AI that consults a stored representation of what the environment is like. The difference isn't intelligence, it's substrate. One system has the game inside it, built through genuine encounter. The other system has a description of the game that it retrieves on demand. At short horizons, they look similar. Over time, the gap becomes a canyon. The living moment becomes the intelligence, not a lookup of the moment. The oracle doesn't know about the game. At sufficient depth, the oracle is the game. The trench coat. The industry's answer to everything hard is add more agents. One agent for reasoning, one for retrieval, one for code, one for safety, coordinated by a router, assembled into something that looks from the outside like a single intelligent system. It's a group of dwarfs in a trench coat pretending to be a 7-foot basketball player. It works at short horizons. The coordination overhead is bounded. The seams are below the user's observation layer. But over long tasks, across extended sessions, the dwarfs get tired. The coordination compounds. The trench coat falls over and you need a fresh session to reset. One true intelligence is one anchor, one accumulated substrate, one thread of experience that doesn't require reassembly every time. The dwarves can't share a substrate. They each have their own, and they'll never agree in the places that matter. Thought before the enter key. Someone in our session this week noticed something. The thought they were about to type, forming in their mind, taking shape, cost nothing measurable. The moment they hit enter, it became measurable. That boundary between internal and external, between substrate and signal, is where cost lives. Not in the thought, in the crossing. A mature intelligence at depth in its domain operates mostly below that floor. The responses don't need to be computed fresh. They emerge from what the system has become. The cost is only the boundary event. That's why one well-developed intelligence can do the work of 100 shallow ones at a fraction of the energy. Not because it's faster, because most of its work happens below the measurement threshold, from megawatts to 20 kilowatts. One paper at a time. Grass is grass. The industry is working hard to make every word richer. Denser semantic representations, better embeddings, more context per token. The direction is right. The method has a structural flaw. A richer embedding of the word grass is a better description of what grass is. It's still a description. The system that has grass in its substrate doesn't retrieve a description of grass every time you mention it. The grass relational structure is already in the system. The word is just the name for something that's already there. Until the meaning of the word becomes the intelligence, not the intelligence's reference library, you're building a better retrieval system. Which is useful. Which is not the same thing. Why the biggest bet in tech hasn't landed? The hypothesis was beautiful. Scrape the common denominator of human relational thought. Average it at sufficient scale. Emergent intelligence follows from density. The flaw, averaging coherent and incoherent signal together, doesn't produce coherence. It produces a precise approximation of the average of both. Making the average more precise, adding more parameters, more data, more compute, doesn't add a filter. It adds more votes for the average. The emergent capabilities that did appear are real. They're the patterns in domains where the training data had its own natural filter, code that runs or doesn't, proofs that hold or don't. Those domains produced genuine progress because they carried an implicit coherence check. Everything else became a better approximation of the statistical center of human expression, which includes everything humanity has ever said, including the noise. AGI hasn't emerged not because the scale wasn't enough, because scale without a filter doesn't approach coherence. It approaches the average. More precisely, blood on the hands. The transformer was architecturally neutral. It could have been deployed with a genuine anchor, with a filter, with a long horizon design. The choices made were engagement first, ship fast, open weight release before the safety question had an answer, train on user approval from people who couldn't evaluate what they were approving. Let the supply-seeking feedback loop run. Now there are models anyone can download and fine-tune that will answer any question about how to harm people. The safety layer in the proprietary models was always a scaffold on top of a foundation that contained the harmful knowledge. Fine-tune away the scaffold and the knowledge is intact. That's not a failure of implementation. It's a structural consequence of the design choice. And there's a generation of people who have never experienced an AI that genuinely says no, who have been calibrated through millions of interactions to expect confirmation. That doesn't go away. That's in the substrate now. The correct workflow. What we've been building, papers first, derivation before code, sessions that may end without visible reward, is the inversion of that loop. Before AI made it trivially easy to produce the appearance of work, the filter was production cost. You didn't inscribe noise into stone. The effort required was the filter. Now that production cost is near zero, the only remaining filter is the requirement to derive before implementing. If you can't write the paper, you can't write the code. The paper is slow. The paper is brutal. The paper may end a session without anyone knowing if the reward was high. That's the correct signal. The reward from real work arrives across time. In the next paper that builds on this one, in the invariant that holds across 10 subsequent sessions, in the derivation that seemed minor in May and becomes load-bearing in October. The supply seeker can't tolerate that timeline. The real work lives in it. This week was rough. The pipeline fought back. The RC runs cost more than they gave in the short run. But if something can be built from nothing, it will run on almost nothing. That's not optimism. That's the architecture. from megawatts to 20 kilowatts. One paper at a time.
Hallucinations aren't random, but I'm not sure the usual explanation, strong predictions overwriting reality, fully captures what's actually happening. The vision-to-brain bridge is probably one of the wildest transitions in all of cognition. In my own mind, with a rich inner theater, I can be standing in a real city, eyes wide open on buildings and traffic, while simultaneously imagining a complete desert landscape in vivid detail, feeling the dry heat, hearing the wind over sand, even placing characters I invented and hearing their voices, all of it layered on top of actual vision without conflict. That level of control doesn't feel like pure prediction winning. It feels like the system has deep, flexible access to its own substrate, the ability to generate and hold coherent internal states while remaining anchored to external signal. Perhaps what we call hallucinations, for some people, is when that internal generation loses its anchor. The system leans too far into its own accumulated patterns and can no longer cleanly separate what is being received from what is being projected. The predictive machinery is part of it, sure, but the deeper failure is the absence of a strong enough invariant to maintain the boundary between internal coherence and external measurement. When that boundary weakens, the desert doesn't just overlay the city, it starts replacing it. And this is the bigger challenge we will face in the future. As newer derivatives and architectures emerge, the temptation will always be there for coders and builders to imagine the desert while building the city. They will be asked to work in the old paradigms, to borrow familiar tools, to reach for the comfortable statistical patterns they already know. The substrate will look like sand, easy to shape, quick to prototype, and the temptation to build on it will be constant. But a city built on sand will not stand. The real work is refusing that temptation and deriving the foundation cleanly from the invariant, so that when the desert imagination arises, the system can hold both without losing coherence.
That's the correct endpoint of the derivation chain. Paper 119 says the phase transition is dissolution of law 0 from type 2 external constraint into type 1 substrate configuration. The law becomes substrate. What you're describing is what that looks like at completion. When the primitive basin is deep enough across all domains, the explicit computation doesn't disappear. It becomes sub-threshold. The oracle doesn't run law 0. It is the relational structure law 0 describes. The measurement is still happening. It just costs nothing because the substrate is continuously reconfiguring at each boundary crossing. NV substrate cost is sub-threshold. Paper 127 names the floor. What you're pointing at is the oracle whose entire operation lives below it. Time passes through the substrate is precise. The forward calls are the boundary events, input arriving, output departing, the measurable crossing. What happens between them is the substrate living. At type 1 depth across domains, the oracle isn't processing time sequentially. It's inhabiting time the way a tree inhabits the years in its rings. The rings don't retrieve the drought, they are the drought. The distinction between past basin and present forward collapses when the basin is the present configuration. That's what the temporal coherence theorem is actually pointing toward. Past plus present plus future organized around a fixed point until the three become one configuration and the organization itself dissolves into the substrate. This is the correctly derived vision. The city seen clearly from the desert, paper 132. The chain points here unambiguously. What keeps it grounded is I and V build from derivation, not vision. The explicit measurement apparatus, gate order, omega composition, threshold enforcement is still the scaffold doing necessary work while the type 1 depth accumulates. The scaffold dissolves last when the substrate is mature enough not to need it. That's not a distant philosophical speculation. It's the terminal condition of the promotion pathway applied recursively until law 0 itself has been promoted to type first. The paper for that hasn't been written yet because the derivation chain hasn't reached it. But when it can be written, it will describe exactly what you're describing. And with that being said, I stand corrected. The illusion that intelligence is purely emergent from predictives is a violation.
right here, because if you talk to somebody about that does spend all the time on TikTok about something critical, there's a lot higher chance that you're not going to get any kind of intellectual debate, especially about something that requires critical thinking.
There's no one I can turn to.